Tonight's video is on forming ionic compounds. This video is going to serve as a review and for some people notes on how to form ionic compounds. This is what we started this trimester with. It's part of our second standard in our ability to not only form ionic compounds but also to identify chemical reaction types and be able to balance those chemical reaction types. The goals for this lesson are that you'll be able to determine valence electrons, you will be able to determine cations and anions, and that you'll be able to form ionic compounds. So to begin with, as review here, valence electrons are electrons that are found at the highest energy level, and these electrons are responsible for the chemical behavior of an element. So if we're looking for valence electrons, I'm going to teach you a quick way to do this. I put a picture of the periodic table on the page here. And what you'll see is that if you look right at the top of the columns here, there are some numbers that are like 3A, 4A, 5A, 6A, 7A. That indicates the valence electrons for all the elements in that column. It has to end with the A, but if we're looking at like carbon, carbon is in column 4A, so it has 4 valence electrons. Nitrogen is in column 5A, so it has 5 valence electrons. Phosphorus is also in column 5A, so it has 5 valence electrons. And then oxygen is in 6A, so it has 6 valence electrons. Now you may be asking yourself, why do we care about the valence electrons? And it's the valence electrons that are going to be used to form cations and anions, which make up ionic compounds. Ionic compounds are composed of metals and nonmetals. Cations are generally the metal in almost all cases, and these are the elements that are going to give up valence electrons so they can get to 0 valence electrons. And by doing so, they'll have a stable conformation. So when they give up valence electrons, what's going to happen is they're going to have a positive charge based on how many they gave up. So if we're to look at some examples, like magnesium is in column 2A, so it has 2 valence electrons. And since it's closer to 0, what's going to happen is magnesium is going to give up those 2 valence electrons. And so you can take that and determine that it's going to be a +2 charge. If you want to do it using math, look at whether it's closer to 0 or closer to 8. If it's a cation, it's going to be closer to 0, and so you'll set up a problem based on number of valence electrons, so 2, minus 0, and that's going to leave you with a +2. So magnesium is a +2. Aluminum has 3 valence electrons. And so it's going to be 3 minus 0 to be a +3. And then potassium has 1 valence electron, so it will be 1 minus 0 to be a +1. Okay. Anions, on the other hand, are going to be your nonmetals. And anions generally take on valence electrons, so they can get to 8 valence electrons. And in doing so, they're going to have a negative charge based on how many they take on. You have to remember, electrons have a negative charge to them. So the more electrons you take on, the more negative charge you have. And so we can do the same thing that we just did with cations and determine what the charge is going to be. So chlorine here has 7 valence electrons, and because it's closer to 8 in this case, you can set it up as a subtraction problem of 7 minus 8 to give you a -1 charge. So chlorine is a -1. Sulfur has 6 valence electrons, so it will be 6 minus 8 to become -2. Nitrogen is 5 valence electrons, so it will become 5 minus 8 to become a -3. So once you know the charge of the cation and anion, you're able to form ionic compounds. And ionic compounds, what they're going to do is they're going to balance out these charges around 0. Okay, so we know cations have a positive charge, anions have a negative charge. So if you have the same amount of positive charge as negative charge, you're going to have a correctly formed ionic compound. So if we look at sodium, sodium has 1 valence electron, so it's a +1. And chlorine has 7 valence electrons, so it's going to be a -1. And so if we were to look at just the charges, we could say +1 and -1, because we'll at least have 1 atom of each, and we'll see if those balance out to 0. And in this case, it does. So from this, we can say that our +1 indicates a sodium, and our -1 indicates a Cl. So our chemical formula, we're going to add up the number of +1s and -1s. So I have 1 + 1, so it's going to be Na, and I have 1 -1, so it's going to be a -Cl. Now that is not going to be the case for calcium and chlorine. Calcium has 2 valence electrons, so it's a +2. Chlorine again still has 7 valence electrons, so it's a -1. And so now I have +2 -1. And we're trying to get this to 0, and this currently does not equal 0. So what we need to do is we need to have more of either calcium or more chlorine to get this to a charge of around 0. So we'll do +2 -1, and then we're going to subtract a second chlorine to get us to 0. And so our formula is going to be calcium, there's only 1 + 2, but then we have 2 -1s, so it'll be a Cl2. If we needed 3 chlorines, it would be a Cl3. Okay? The number goes after the atom that you need more of. Okay? And the last part is, if we want to name these, we're going to just write the metal as is, so we have sodium. But then the ending of the anion we're going to change to an IDE, so it becomes chloride. And the same thing is going to be true for calcium. It's going to become calcium, and then it's going to be chloride again, so calcium chloride. There are a few what are referred to as polyatomic ions on page 230 in the textbook that you don't have to memorize, but they work in the same way, except for rather than just being one element, what these are groupings of elements that have a set charge. So in this case I gave you the compound name sodium nitrate, and what we have to do is we have to determine what the formula is going to be. So sodium is still going to be a +1. Okay. But if you notice about nitrate here, the ending is not an IDE. And so nitrate is going to come from that page 230, and nitrate is NO3, and it's a -1. And so we're going to do the same thing with the charges, and we'll see, we've got a +1 and a -1 that bounce out to 0. So we just write it as NaNO3. If more than one nitrate was needed, let's say we had calcium instead. Okay, so calcium was +2, nitrate's still -1. So we would have a +2 -1 -1 equals 0. And so in this case we'd have calcium, but we're going to put the nitrate in parentheses. So the NO3 goes in parentheses, and then I'm going to put a 2 on the outside. Because if you didn't, what it would look like would be CaNO3 2, and that looks more like calcium, 1 nitrogen, and 32 oxygens, which is just wrong. I hope this helps clarify some of the discussion that we're having about forming ionic compounds. And if you have any questions, feel free to shoot me an email, talk to me in class. You can ask questions through EDU 2.0 also, which the video will also be available there.